Okay, this is 9709, October, November, which one? 2021, question 5. Whether you're doing AS or whatever exam you're taking. A railway engine of mass 75,000 kilograms is moving up a straight hill inclined at an angle alpha to the horizontal. They said sine alpha is equal to 0.01 and the engine is traveling at a constant speed 30 meters per second. The engine is working at 960 kilowatt and there's a constant force resisting the motion of the engine. So Phi resistance force. Okay, find the resistance force. What do we do anytime you have a straight hill? Draw your inclined plane and your FPD. When you're working with forces, always draw your inclined plane and your FPD. This would be the weight of the train or engine or whatever. This would be the y-axis over here. Oh, no. This would be the y-axis over here. And this would be the x-axis, right? And over here we have the angle alpha. Let's fix our FPD. Let's make it over here. Like this. X and y. Take it down. Let's use a different color for the weight. Take it down. The angle between the weight and the vertical is alpha. The weight is split into Wx and Wy. You obviously have the normal. And you have the engine's thrust force, call it E, and you have also the resistance force that's resisting the motion. So we're moving at a constant speed of 30 meters per second. So that means sigma Fx is equal to 0. The sum of all forces on the horizontal plane is 0. So what's on the right is equal to what's on the left. Okay, so E is equal to Wx plus R. Let's start solving. We know that E is the force by the engine, which is just equal to P divided by V, right? Because the force E is equal to P divided by V. Why? Because P is equal to force times velocity. So force is just equal to the power divided by the velocity, right? So E is equal to the power divided by the velocity. So 960 times 10 to the power of 3 divided by the velocity it's moving at is 30. And do this on a calculator. You're going to get, by 30, you're going to get 32,000. So E is equal to 32,000 newtons. Wx is equal to W sine alpha. So, which is equal to mg sine alpha, which is equal to the mass, 75,000, times g, which is 10, times sine alpha, which is given in the question as 0.01. If you do this on your calculator, 75,000 times 0.01 times 10, you get, again, 75,000. Oh no, I put 750,000? Yeah. Okay, you get 7,500. So, now can I find R? Obviously I can. R is equal to E minus Wx. So it's going to be, R is equal to 32,000 minus 7,500. And you're done. 32,000 minus answer. You get 24,500 newtons. Let's check the marking scheme. The driving force is whatever, the energy, the E force. And then we know that dF minus Wx minus R equals 0, or what we wrote over here. And then the resistance force is just 24,500. Very, very easy. Part B, the engine now comes to a section of the track where it's horizontal. At the start of the section, the engine is traveling at 30 meters per second, and the power of the engine is now reduced to 900 kilowatts. So the power is 900 kilowatts. The resistance to the motion is no longer constant, but in the next 60 seconds, the work done against the resistance force is 46,500. So we have resistance, but it's not constant, but they told us the work done against the resistance force is 46,500. Okay, this sentence is very important. Okay, you need to understand what this means. Work done against the resistance force. What does this mean? Work done by the resistance force is equal to negative, let's call this, I don't know, let's call this I don't know, R prime, work R prime. Yeah, it's equal to negative work R prime. Why? Because we're saying it's against. Okay, so that means the work done by the resistance force is equal to negative 46,500 kilojoules. Okay? They're asking us to find the speed of the engine at the end of the 60 seconds. We know the first speed, we know the second speed. We're working with work, and we have power and time, which also means we're working with work. So when you're working with work and kinetic energy, what do we know? We know that delta K is equal to the net work. And the work net, when you have a resistance force, work net is equal to the sum of all the works, right? So it's equal to the work done by the engine plus the work done by the resistance force, right? And the work done by the engine, we have the power by the engine and we have the time. So we know that the work done by the engine is equal to power times time. Because you guys know that, let me write it in a better way. We know that power is equal to work divided by time. So that means the work done by the engine would be equal to power times time. So it's 900 kilowatts times 60, which is, let's do it on our calculator, 45,000 kilojoules. Okay, so this is the work done by the engine. So let's solve this now. 900 times, sorry, 60, not 50. I don't know why I did 50 by accident, huh? So it's 54,000 kilojoules. Okay, so we know that it's 54,000 kilojoules work done by the engine. Work done by the resistance, we said it's negative 46,500. Work net, we said, is equal to delta K. What's delta K? Delta K is equal K final minus K initial. So it's half mv final squared minus half mv initial squared, which is just half times the train is 75,000 times velocity final squared. We don't know, we're trying to find it, minus half times 75,000 times velocity initial squared was 30 squared, right? Okay, so this is delta K. So let's reorganize everything. We know W net equals WE plus WR. So half times 75,000 velocity final squared minus half 75,000 times 30 squared is equal to W done by the engine. Remember, you can't keep it in kilojoules, so you're going to multiply by 1,000. So it's going to become 54 million plus work done by the resistance force, which is negative 46,500. So I'll put minus. And remember, it has to be in joules, not kilojoules. So 46,500,000. Put this on your calculator and solve. So you do 54 million over here. 1, 2, 3, 4, 5, 6 minus 46,500,000. 1, 2, 1, 2, 3. You add, solve, I'm just solving. So plus, you take this other side, so it's going to be plus 0.5 times 75,000 times 30 squared divided by 75,000 times 2 square root, and you get 33.166. We're looking at two significant figures, so you could say velocity final is equal to 33 meters per second. But let's see, I think they put 33.2. Okay, I don't know why they use three significant figures. In the exam guideline it says for non-exact numbers rounded to three significant figures. So this one, you say 33.2 meters per second. For the A level, it says at the first page of the question paper, for non-exact numbers rounded to three significant figures. For SABIS, I guess two significant figures would be fine here. Okay, so that's all you need for question 5. Thank you so much for watching, and good luck.